I forgot.
No, we are doing.
No, mail I have done morning only, no?
Yeah, morning the mail have visited.
Oh,
That only link
in
is
that
there.
infolette Zoom link is there.
Okay, okay.
Yeah.
So now what
Now
about
I am doing YouTube link also.
okay? What about students, ma'am?
Students already started
No
joining.
classes will not be there.
Okay. Good afternoon, Dr. Vandana. Can we start?
We'll start in 5 minutes, ma'am. Just 5 minutes, huh?
Okay.
Swati, we will start now. Should we start, ma'am? Geeta, ma'am?
Yeah, we can start.
Okay, ma'am. Good afternoon. Welcome to all for this talk on augmented reality and virtual reality organized by Department of CSC KSSCM in association with Bytes. I'm Swati Dalla, will be hosting today's session. I would like to welcome our eminent speaker, Dr. Geeta Prakash, for today's lecture. Welcome you, ma'am.
Thank you, Mrs. Swati.
I would like to heartily welcome Dr. KNP Murthy, Chairman Bytes and Vice Chancellor of Dayanand Sagar University. Welcome you, sir. I would like to extend my welcome to Dr. KVA Balaji, CEO of KS Group of Institutions. Welcome you, sir. I would like to extend a special welcome to our beloved Principal Director, Dr. K. Ramanarsimha, sir, for today's lecture. Welcome you, sir. I would like to welcome our management of KS Group of Institution in their absentia. I would like to extend a warm welcome to our HOD, Dr. Vandana ma'am. Welcome you, ma'am. Thank you. Last but not least, I heartily welcome all the participant faculty and students from the various institutes for the today's talk. Welcome you all. Now I request Dr. Vandana ma'am to introduce our speaker for the gathering. Good afternoon, all. I welcome you all. Today's speaker is Dr. Geeta Prakash. She has a PhD in communications from NIT Surathkal. She is a focused and seasoned professional capable of building competencies in contemporary and latest technologies. With a strong knowledge in agile methodologies, design thinking, creating learning frameworks, she has mentored several interdisciplinary projects in her experience of over 25 years. In addition, she has a PG diploma in environmental law jointly offered by National Law University Delhi and World Wildlife Fund. She is an IBM certified data science professional and has completed several certifications in project management, including managing project risks and changes by University of California, Irvine, and financial markets from Yale University. With interest in renewable energy, she has a certification on solar energy and electrical system design from University of Buffalo, New York. Madam is currently pursuing Master of Business Laws from National Law School, Bangalore. Now I'll hand over the session to Dr. Geeta Prakash. Over to you, ma'am.
Thank you, Dr. Vandana. It's a pleasure to be here So without much delay, let me just share the screen. Today we shall be talking about augmented and virtual reality. There are a lot of applications which I'm sure students will be very happy to understand how much it is playing a very important role in their day-to-day activities, especially with the gadgets that they have. And I think now with virtual classrooms, I'm sure they have been enjoying these applications on the phone. So today they will actually understand how much and how different the technology has grown over years. So let me just share the screen. And apart from the slides, I have included a couple of videos so that it will motivate students to understand what the technology is. Since this is a virtual session, to keep them occupied, I thought it is good to show a couple of videos where they'll understand things better. So let me just share the screen. I presume it's visible.
Yeah, it's visible,
Yeah,
ma'am.
good. So we shall be talking on what is virtual reality and what is augmented reality. How are they different? We also have hybrid modes of operation. We'll also look at the different applications which have been probably, I think, due to this pandemic. AR and VR has been very, very extensively used for applications which people, never thought that it would pick up so easily. So I would actually like to start. Sorry, with a video which is very, very familiar to students. So let me just play. I have two videos which I have them ready. I have to just share them.
The first thing in this feature is just to kind of get a sense of a flat surface. So I just did that, and now I see this tall grass pop up.
So everybody masks the plane detection part of the experience.
Mm-hmm. Yep, turning that into a mini game itself, right?
Right.
And then I'll tap on that. Oh, there we go. A bar back. So it's out there. How we basically detect.
But they wouldn't know that in the pre.
Yeah, before, correct, yeah. Before there was just no awareness for the Pokemon. So for us, this is, we're calling this feature AR Plus, as opposed to just AR, which was the previous name. Because now the Pokemon kind of have more awareness and, all the kind of finer details on them. And I have that expert handler now.
I shall be sharing another video and then I'm going to talk about them.
Around us. Last year, we introduced landmarkers, which enabled the Snapchat camera to understand individual buildings and allowed lenses to interact with some of the world's greatest landmarks. Now, we've continued to evolve the technology to understand and augment, able to build up a digital representation of the physical world. A point cloud representing the distributed cloud compute, we're able to map whole city blocks. Meet local lenses. Now, Snapchatters can join a persistent shared AR together, collaborating creatively and experiencing a whole new dimension of AR. As our team continues to build these new.
So, two applications which I'm sure students have used for understanding and feeling for the AR and VR applications. Two, I think which one is Snapchat, which students have been very frequently using, and you could see how much of a change in the environment was brought about by the application. So with these two, let me just go back to my slide, and then we shall talk about what exactly AR VR is and how the technology actually works. Uh, so both of these technologies bridge, or they have a very almost a seamless boundary between real and the digital world. People can immerse themselves in the new world. It could be either virtual or a real world with virtual objects, and it gives a different kind of a purview for opening up different business opportunities and also learning opportunities. As much as students have been also learning about AI and ML, this AR and VR applications also make use of AI and ML very, very extensively. We shall try to see what is the difference between AR and VR, and go on to understand how some of these work, and also the gadgets that are required to study or to probably execute some of these applications. So, in virtual reality, it is a completely artificial environment, and the person gets immersed in the virtual environment. So, it is not going to be related to the environment in which the person is actually sitting. If it is augmented reality, the person would be experiencing the real world environment, but there would be virtual objects which would be present in that real environment. So the real world environment would be enhanced with these digital objects. So that is augmented reality. Mixed reality is a virtual environment with a real world, and it is also possible for people to interact with these objects. So that is mixed reality. So I hope the difference is clear. Virtual reality is a totally artificial environment, and the person gets immersed in that virtual environment. Augmented reality is with a real world environment, but there are virtual objects. In mixed reality, there are virtual objects, and the person can also interact with the real world and the virtual environment. So you can see here a simple example of virtual reality, where the people are in a show, or in a theater. So it's just a virtual environment. It has no bearing on where the person is sitting. But if it's augmented reality, it would merge the real world with the virtual objects. We'll see more examples on these. And what is the requirement for this? Both for VR and AR applications, they need special glasses. And these days, it is also possible to use smartphones. So we'll again see. So to experience Snapchat and Pokemon Go as an AR VR application, it was possible. Most of you saw in the video that it was possible through the mobile phone. Some other applications have been in medicine. I'm sure you've heard of enabling the healthcare system. Even in logistics and automotive industry, also in marketing, we'll be seeing a couple of examples on this or other applications. Also, currently, since people are not able to travel across countries or across places, or it is limited travel, it is possible to train others sitting from somewhere else. So we'll again see how this has been made possible. So you can see some of the applications here. Children are playing in a park, and if there are some animals which have been extinct and then people want to experience this, it is possible to include those as virtual objects in a real environment of a park. So that happens to be augmented reality. And if the kids are able to interact with it, it becomes mixed reality. It could also be a visit to museums. It could also be people from the same family talking to each other across continents or across countries. One of the other applications which has generated a good amount of interest is with respect to fitness or with respect to training. So if there is a group which is running, they can have a virtual environment which they can feel as a trainer is also along with them. So probably it can motivate them to perform better. Yeah, so specifically to understand virtual reality, you are totally immersed in the virtual environment and you don't see the real world around you. It's a totally simulated environment where the person is taken to a different place. It could also be a different time. And the person who is experiencing virtual reality can completely control what they are doing, where they are going, what are they looking at. But it's a totally simulated environment. Could be a different place or could be a different time. So virtual reality could be used very well in education, or these days if people want to experience visiting other places, though as much as it is virtual, but what they couldn't have done at all is now possible because of virtual reality. So you can, probably visit a museum, something like this. You can be there, you can roam around, and you can do things like that. So this is virtual reality. It is also very useful in architecture. So what happens is, currently people would like to see different designs of buildings. They would like to see different structures. So sitting somewhere, people can actually experience this virtual environment. They can understand how the entire building would look like. So if any modifications are required, they can automatically suggest it to the architect or the builder. So you can have better designs, you can make better utility of the space that is available. Also possible for meetings in virtual rooms, sharing displays and screens with others. So this is also going to add value. Now looking at augmented reality, what did we say is the difference between augmented reality and virtual reality? There it is a simulated environment, and the person doesn't actually feel anything about the environment in which he or she is sitting. But if it is augmented reality, you can see the real world around you, but there is also going to be an overlay of virtual objects or any other video. So AR would superimpose computer generated images on the real world view that the person has already got. So you can see here in the top screen, top image, that of course, like I mentioned, there has to be this gadget, but the person can see a lot of objects or the machinery which is present. So it is helpful in technical support and in troubleshooting. So there is a video which I will show you. So people have used this very extensively now during the pandemic to maintain machines. So economy was down, and businesses were actually slowing down. Lot of machines, because they were not utilized, they needed some maintenance, but that was not possible because the service engineer was sitting somewhere else and the machine was somewhere else. So they have used AR and VR extensively to service these machines, and they've enabled the engineers in the workplace itself, so they didn't need the specialized engineer to go there for minimum support. It helps in connecting remote experts to, again, like I said, servicing machines for any other application. So mixed reality, like what we said, it is very similar to AR, but you can have an experience of both the virtual and the real environment and also interact with it. So what happens here? You need additional technologies or additional gadgets. So you can see here at the bottom, Microsoft has brought out what is called as a HoloLens device. I'll be showing you a video of what this is and how it works. So this is mixed reality. You can see the person is with the real environment. There's also a simulated environment, and then the person can interact with it. So that is mixed reality. A couple of examples of mixed reality again here. So let's briefly see what is needed for AR and VR applications. What are the requirements? So it is again dependent on the application, but some of these are going to be standard requirements, be it AR or VR, because they need to simulate this environment and also get the actions performed by the user or by the person who is experiencing it. So what are the different applications in a very diverse set of scenarios? It could be in education, it could be in mechanical maintenance, it could be in the healthcare system. What are the hardware and components that are required? We'll also have a look at the software a little later. So basically, if you need to interact with it, we need to have a couple of sensors. And if the person has to talk or speak, then we need audio sensors, which means we need microphones as well as loudspeakers. Obviously, we need camera to capture. So visual displays are a must. And definitely internet connection is required. So it could be through Wi-Fi. It could be, other industry specific equipment based on the application. So a couple of standard things we need: microphone, speaker, camera, Wi-Fi connection, and if you are interacting with the environment, the position or the localization of the person or the object has to be done. So which means GPS is also required. So these are basically some of the salient components that are required for a basic AR and VR application. So now in this slide, you can see a little more in detail what are the hardware, middleware, and the software components. So in the hardware, you need a very high processing power. So there is a requirement for a central processing unit. Of course, because there's video and image processing, you need a GPU. There's a graphic processing unit. Also, anything to do with vision, image processing, then a lot of gadgets to identify the movement. So there are accelerometers, gyroscopes, similar to the units on your mobile phone. So MEMS, that is micro electromechanical systems, lot of these very very small objects or devices which are embedded in these AR VR gadgets fall under the category of MEMS. And of course, there's a lot of storage that is required, so there would be memory chips. So what falls under the category of hardware and the subcategory of semiconductors would encompass all of these things: central processing unit, different processors, then MEMS devices, and memory chips. The other hardware that are required happen to be motion tracking devices. You have cameras, you need 3D lenses, and different kinds of goggles. Of course, all of these connected together become the headsets. So in the headsets, there are two kinds. One is tethered and the other is untethered. So tethered means there would be a wire that is getting connected to the headset. Untethered would mean there is no wire. So wired and wireless. I'm not going into the detail of these things, but just the technical jargon we are going to see. In the middleware, we need different platforms. Some of these are the typical AR VR engines that are required to manage this. And of course, in the software, there are a lot of applications. I'm not going to talk much about them because it's going to be very detailed. So some typical examples would be anything to do with standard, AI and ML applications that students have already learned or probably learning. So all that processing part of it falls under the category of software. So let's have a look at some of the components which are present in the AR VR glasses. I'm sure you would have seen them. So let's just understand some of the components here. One important thing is the directional speaker that I mentioned. Why directional? Because it should be able to capture anything that happens in the entire environment. Of course, we have tracking and recording cameras because movement is very important. And then you have audio microphones, like I said, if the interaction has to happen, and very good internet connectivity. Also a lot of cameras and night vision sensors are required based on the environment, whether it is during the day or night, whatever it is. And there has to be a sensor which can sense the amount of ambient light present, so we need ambient light sensors. And eye tracking cameras, will shortly see an application where just by identifying the movement of the eye, there could be variation in the simulation. So this is probably an AR VR glass with some important components that you need to understand. So let me show Microsoft's HoloLens, which I just mentioned. It's one of the probably a very widely used gadget. So let me just share the video.
Today, I get to show you something very special.
Let me just share the screen.
something we've been looking forward to for many years. When we set out to build HoloLens 2, we wanted to create something that you didn't need to learn how to use. You should just know it. And it also recognizes the world. Welcome to my mixed reality. Now, I've seen many people on HoloLens. The first thing people do when they put on the device is they or I can rotate it. Or move it. That's right. We are touching holograms. This is an app I've got called Spatial. Let me just put it right there. I've got another app here called Vuforia View. Now, it's a little big, so let me just use 2 hands here to make it smaller, and then rotate it so you can see. There we go. And then let me put it down here near Spatial, maybe make it smaller. Yeah, that's nice. All right, now let's switch gears and talk about a different kind of application. I've got a browser over there, but it's kind of far away, and I don't really want to walk over there, so let me just call it over with my voice. Follow me. This is a browser that's running Microsoft Teams, which is a tool that we use back home to collaborate. Let me see what the team's been working on. Okay, it looks like they've got a surprise for me in the Playground app. I just have to say the words show surprise. All right, so let me just open up that start menu here, and then place the app, and then launch it. So now we're actually exiting my mixed reality home and going in. Now, the interaction that really took home the cake, though, was this pinch slider. The way that works is you just pinch it and move it wherever you want. And what we found was that people really like that tactile sensation of their fingers touching as they grabbed and then released. And across the board, for all interactions, ooh, look at that hummingbird over there. It's gorgeous. I wonder if it will fly to my hand. Yeah. Oh, wow. This is beautiful. I just love the way that it's following my hand around. I've got to tell the team, they've done a great job. And in fact, I don't even need to use my hands to do this because I can use my eyes and my voice. That's right. HoloLens 2 has eye tracking. So I can just look over this browser here and look at the bottom of the screen to scroll it. And then send my message. Start dictation. The hummingbird looks great! Exclamation mark. Send.
Can you tell everybody a little bit about what you're seeing?
Sure. I can see your lifelike avatar.
Stop what you're doing for the next 30 seconds. Let me show you something I've never done before. Hey guys and gals, my name's Jason Bond.
Avatar, which we generate in seconds from a 2D photo.
Art classic brands like Barbie and Hot Wheels and Fisher-Price.
And it becomes a digital sticky note, which I can just grab and stick right onto the fire truck so that we can have engineering revise this later.
Design process to ideate and generate inspiration. Okay, guys, let's come up with some ideas for a line of aquatic toys.
Yeah, how about sea turtles?
Oh, that's really cool. Let's try sharks.
That's cool. How about jellyfish?
So all we have to do is say the words and they're instantly visualized right before our eyes. You can even click into one of these bundles and they expand into a full-blown internet search, complete with 3D models, images, and...
So I think, most of you were able to see how the HoloLens works and what all was possible. So now you are able to relate what goes into the headset and also what are the components that are required. If you saw what she was mentioning, she was saying that there are eye trackers which could actually figure out how she was moving her eye, and then she could send an email, she could also communicate, and it was also through voice. So whatever I said just now, the components or the sensors which are a part of the lens fall into all of those segments of audio, video, visual display gadgets. All of those things would encompass the sensors that we just spoke about. So let me just go back to the presentation. Okay, so these are some of the gadgets. Anyway, we've seen them and we've understood. Um, if people don't have the headset, some of the AR VR applications can also be managed with the mobile phones. So now for different applications, there is also a requirement of 5G, mobile broadband services. So it can take the AR VR experiences to the next level. Why it becomes, probably a requirement at a later point of time would be dependent on the applications. So 5G gives very low latency. That is, your transmission is going to be very, very fast, and then it also gives a uniform experience. So if the person is moving, then there is no difference in the experience because of 5G. And 5G also gives gigabits per second, multi gigabits per second experience, so the throughput is very good. So 5G could enhance the experiences of AR and VR. So when would 5G be a requirement for AR VR experiences? It could be for video streaming when a person is traveling in a vehicle. It could be for remote controlling, and also very good immersive content with respect to sports. So in sports, you need everything to be very fast. So you need a very high throughput and low latency. So to have AR and VR applications related to sports or any other very fast moving applications, 5G would become a requirement. So we just saw about video streaming. I shall come back to this later. I'll just run through the slides and I'll come back to it. I'll also show you, how people can make some of these very small headsets by using Google Glass. I'm sure, there is, it's like a do it yourself. I'm sure some of the students would have already tried, but I'll show you how that can be done with your smartphone. But I'll just go through a couple of slides before that. So basically, let's understand what all go into the VR system. So the person would have a headset or a gadget, and there has to be an input, there has to be an output. So we've already seen from the past video what are the different inputs. It could be voice, it could be the movement of the eyeball, it could be just an image. All of these become inputs. Also, because of movement and localization, you need GPS data. You also need inputs from the gyroscope or the accelerometers because you're making movement. So all this would be input data, and you see that is going into the processing part of it. So there'll be a VR engine, and there's a hardware also which is going to do all this processing. Of course, you need a lot of storage to get this data, do some processing. After that, the data is again sent to the output devices, and there would be actuators or sensors which would react to the input that is given. So basically, this is a virtual reality system which can perform the tasks of the user. So we've seen, the HoloLens. Apart from that, there are different kinds of headsets which can be used for AR and VR. Also, smartphones or tablets. All of these things could be used for AR, VR applications. So briefly, what are the different components? You can see the different sensors that are required. Let me just talk about some of them, which is required for the AR VR ecosystem to function properly. The head mounted device, which we've already seen. So for augmented reality, some of them could be Google Lens or HoloLens that you saw. Different gadgets are available. for virtual reality, of course, you have, other devices, Samsung Gear, any of these things could be helpful to use them for VR applications. And we also need processors. That is what we've seen. So who are the pioneers in processes, making processors specifically for AR, VR applications? We have TI, Qualcomm, Intel, all of these people, they do them. For audio video applications, of course, we have NVIDIA, Qualcomm, AMD. They are the ones who have been supplying the processors for graphics or even audio processing. And then you need memory devices. It could come, from Samsung or any of these companies. Cameras are required, different kinds of cameras. It could be 3D cameras, it could be different kinds of scanners. You would also need 3D lenses, display gadgets, position trackers, motion sensors. Where are the applications? I'm sure I don't have to talk about it. Extensively used anywhere in games, and then healthcare system, even in social and commerce applications. So we'll have a look at the applications, different applications at a later point of time. Of course, they're also used, I think I'll talk about smart glass, that is Google Glass. I'm sure you've heard of it. HoloLens you've seen. So the different gadgets, could be the tablets or the phones, smartphones. It could be Google Glass, it could be HoloLens. We've seen this now. So let me just show you the previous video. That is how to make this headgear.
Hey, what is up thing? So VR started with the Air Force actually.
Let me just share the screen.
You are watching Cold Fusion TV. Virtual reality and augmented reality. They seem to be hot buzzwords which we've all heard before. Point of view of your brain, you're somewhere else. It's a form of mental teleportation.
Just a second.
You look around, but the idea is to trick your brain into thinking that that's your new reality. So VR started with the Air Force actually as part of their flight training program, and it's flight sim. Now obviously that's much easier and cheaper to have new pilots practicing stuff like two kinds of VR headsets. Type 1 is the accessory that you plug your smartphone into that becomes the screen. So something like Google Cardboard or Samsung's Gear VR. And then type 2 is the standalone unit that does everything. It has a gyroscope and the screen and everything built in. So that would be something like Oculus Rift or HTC's Vive. Both types, of course, have these lenses that help your eyes focus on the stereoscopic image that's right up against your face, which isn't great for your eyes, by the way, but whatever. And they all have this gyroscope and accelerometer that help track your head movement, and that's what helps put you in your own little world. So I got to take a closer look at one of the second type at Mobile World Congress this year, the new HTC Vive. And this is something people were getting really pumped about. It's a prototype for now, and the final version might not look exactly like this, but your phone, as the VR engine and the screen, it's actually a little bit more simple. Your phone already has a gyroscope and an accelerometer built in. So all of your movements around that 3D world will come from that. But these don't have the advantage of sculpting the optimal VR experience. I mean, it's kind of like an accessory, and it's a little bit weird to like clip your smartphone into some VR headset that uses your phone as the VR engine and the screen. It's actually a little bit more simple. Your phone already is really hard. There are so many things you have to consider. The pixels per inch of the display, since it's right up against your face and it's magnified. And then there's the field of view, since you want it to be as immersive as possible. And the pixels per degree, since everything is magnified and so close to your face. There is good hope, though. I've never seen an industry go so fast from zero, like almost nothing.
So you understood what are the requirements now. You need a full 360 degree vision. They should also take care of how close the environment is to you, the virtual or the virtual objects that are there in the real environment. So these are the requirements that have to be catered to in the gadgets that are being used. Just a minute. Let me just go back to the slide.
Until hours even to get. They sometimes have a malfunction or even a shutdown. It's really.
Let me just share the screen. This is how machine repair is being facilitated through AR and VR application.
Delays production, and up until now what they usually do is getting the expert on site. That takes a lot of time for the expert to come, see what the problem is, maybe get back to get the right spare parts and do the actual repair. When we today, they do not always have this information with them. It's complicated, it's not always up to date. It can run up until hours even to get the fix done. And that's a lot of money wasted there. You are in direct contact with the expert who is not on site. You can have audio connection with him. The expert can see real life video, and you can chat with him by text messages. It's all within the same application. And on top of that, he can be helped by the expert by augmented reality annotations. So the engineer in the field via his smartphone or smart glasses actually see these annotations projected on the machine that he's working on. So step by step, he can fix the machine in the right order, in the right way.
So I'll go back to the screen again, but I hope you've noticed that there is this person sitting in some other place. He's actually helping the other the service engineer to repair the machine. And if you have observed, I'll show it again. So you can see the person was actually drawing those circles or the arrow marks in green and yellow color, telling the person what knob he should turn, which would not have been really possible without AR and VR. So let me just complete that particular video. Not exactly full, but at least a part of it.
With FieldBit, the customers are helped much quicker. For once, sometimes they can do the repairs much quicker, and the cost is much lower for our customers. So the customer satisfaction is really high.
I really like the simplicity of the app. The train drivers have a lot going.
So in the next part, you could also see a glass or a tablet that was being used in place of the headset. So the first person was actually using a headset. In the next part, you could see, there was this tablet kind of a gadget that was being used. So overall, what is required, you understand that there has to be very good internet connection. Like we said, 5G is very good. if you have one. But otherwise now internet broadband connections are a big requirement, because you need to transmit the video and the audio as well. Let me just go back to the slide. Okay, I still have a couple of videos to show, but I'll just talk about opportunities for AR and VR, and again I shall come back. Um, so why are opportunities for AR and VR very different from what it was 5 to 10 years ago? So the point is that the requirements have totally changed now with smartphones. I'm sure there are different applications that have come up, and people have also started using these applications. So the need to have AR and VR is very different from what it was 5 to 10 years ago. It's kind of become ubiquitous, and people probably cannot manage without some of these applications. That's how it's been. And if 5G becomes accessible in the future, then the AR and VR content transmission is also going to be very good. So my advice to students who are here listening to this talk is, apart from looking at different technologies, also look at understanding 5G technology. If you could do a couple of learnings and understanding the technology, a little bit of the maths behind all of these concepts, I'm sure it would help. And of course, the standard buzzword of AI and ML plays a very important role everywhere. It has a very good a role to play in AR and VR too. And students who are interested, who are kind of artistic and into the design, they are more interested in development of content. If you're good at thinking of different ideas for creating a virtual environment or a simulation environment, then I think AR and VR is going to be a very good opportunity for people who are creative with respect to art, in different forms. It could be in creating this environment or even using AR and VR for art. I'm going to show a couple of videos for that as well. And then it's going to be probably reducing the time that is required for people to even utilize these services. So how AR and VR is going to be different for different applications. Okay, so there is a case study of IKEA. Again, I shall come back to this. Just a minute. Let me just. Okay, I have the previous video to show. Let me just go back to that. Just a minute. I'll just. I'll show for artists and creativity. Let me just go to that video. So this has no audio, but it is for creating content with art. So let me just go to that application. So you can see what are the different gadgets that are required apart from the headsets that you have already seen. So something to draw, something to pick the color. Okay, I'll show another one where it is used for training. So let me just go to that particular video and I'll come back to the slides. Just a minute. I'll just share it.
Honeywell Connected Plan, the immersive competency, helps us train people better and faster in a different way. When we looked at competency, we can now bring that to your site. You just turn on method by pulling things through, and using immersive competency, we can now bring that to your site. You just turn on the HoloLens, you start learning, and when you're done competency, we can now bring that to your.
Okay, so this is how training is being done. So I'll show you a training session which Honeywell has demonstrated. So what they're trying to do is that the equipment is actually not present in that scenario. They're creating that environment and they're training their engineers. So let me just show you this application.
Site, you just turn on the HoloLens, you start learning, and when you're done, you feel competent when you walk into the field to provide that same task in the field. One of the great opportunities provided with Honeywell's immersive competency is that you can now work together as a team during the learning. Here, Mark in the middle is a trainer showing his two trainees how to change a model in a faulty model in the Honeywell Safety Manager. The trainees are together in the same room with the trainer in this demonstration, but can be anywhere in the world and still collaborate on this same model. Go ahead, Mark, and show us how you do it.
So you could see in that video. So you could see in that video that initially there was nothing to do with the machine, but they were able to create that virtual scenario for the machine, and then they were able to perform the training. I'll show you another one, and then we'll talk about it. I'm sure you've all heard of IKEA, right? So IKEA has created an amazing platform. So let's understand the technology in this, and then go back to the video. So I'll just share my slide with what IKEA has done, and then we'll go to the video. So what they've done is, I'm sure you've all used QR code and those applications with your mobile phone. So same thing is true here. So they have a brochure. So you could have, the, what shall I say, the advantage of sitting at home, keeping those furnitures of IKEA in the places that you would like the most, and then you can pick. And also to decide what furniture you want, you could scan on the catalog that you have. You can browse through the the physical catalog you may have, You can browse through it, you can scan it, and then you can keep the IKEA catalog in a place where you want to put the furniture, and then you can choose the furniture. So it's just putting the catalog in a place, choosing what furniture you want, and then that furniture is actually going to appear there, and you can feel for it and understand how it would look like. So it's an amazing application. So let me just share that screen. Just a minute, I think. Yeah, so I'll just play this. So you were able to see. I also want students to relate it to the different sensors that we have understood. So placing, localization, lot of these things involve GPS and other things. So you could see in this particular video how placing the catalog itself was actually telling where these people wanted to keep the object, or whatever was being sold from IKEA. So let me just go back. Just a minute. So this is another one where there is collaborative and virtual augmented reality for remote collaboration.
In this video, we present COVAR, a collaborative virtual and augmented reality system for room-scale remote collaboration.
Let me just share it. You'll see it's a very different kind of application. Let me just share it.
And interaction. Our system reconstructs the real environment of an AR user and shares it with a remote VR user, which makes the VR user feel as if he is in the same space. We represent users with a virtual head and hands. In this way, the local user's hand poses, such as pointing and thumbs up, are recognized and shared with the remote user. Our demonstration is novel for 3 reasons. The first is that we have integrated eye-tracked gaze input into a collaborative mixed reality system between augmented reality and virtual reality. Eye gaze input is used for both interaction and communication. The second novelty is the sharing of awareness cues between users to improve their collaborative experience. And for the third innovation, we show that collaborations between AR and VR can be enhanced beyond a typical collaborative experience. We explain these novelties with more detail in the video. Our system supports 3 primary inputs: eye gaze, head gaze, and hand gestures. All of these inputs provide our user's ability to scale himself bigger or smaller relative to the real world. In the normal scale mode, we have a 1-to-1 scale between the AR and VR users. In the miniature mode, the VR user is a fraction in size compared to the AR user. In the God mode, the VR user can be bigger than the AR user and her room. Our second technique shows the VR user snapping to the AR user's perspective, where the current VR user's head position is set to that of the AR user. To avoid simulator sickness, the VR user still has an independent head orientation and minor control of his head position, offset from the default AR position.
I'll just go back to the video, but I want you to observe that the headset that the person is wearing is actually connected through a wire. So I had mentioned about tethered and untethered. So some people feel that this is kind of a disadvantage in a lot of applications where it is wired. So I'll just go back and I want you all to see one of those in the left corner where the headset is actually connected.
We have developed applications and are constantly improving them to showcase our system. This application is a collaborative scene authoring application where users can collaboratively design, create, and assemble models in mixed reality.
Okay. I'll show you another application. So in this application, you will see there is also an e-commerce application which has been incorporated into an AR VR application. I don't know if you have heard of it, but a lot of these companies which sell paints, to kind of paint your house. It could be for the walls, it could be for the doors, or any of these things. So they give you an opportunity to visualize what kind of color would suit the room. And once you have done it, you can also go and buy that particular product. So Asian Paints was actually offering such a service. This is not from that, it is from another organization, but I'm going to share it. So you will know the reason why I'm showing these different applications is for students to understand that there are a lot of opportunities for them to envision themselves apart from considering only AI and ML applications for AR and VR. So you could very well relate e-commerce applications, even merge the logistics applications along with AR and VR. So let me just go to that video. So you're able to see the merging of the e-commerce application where the person could also place the order for a particular colored paint. So before going back to the slide, a couple of things which I would like to add. Like all other applications, there are a lot of challenges in this as well. Some of the gadgets, if you're using your mobile phone, of course, a lot of applications are possible. But if not, some of these gadgets are quite expensive. If you're looking at the HoloLens or any of these things, they are quite expensive. Also, along with these, the challenges of data security, the privacy of the data, the privacy of where you are sitting, the amount of data that is collected in your environment. So all of these things, as much as they have been challenges in other applications such as AI and ML, they continue to exist even in AR and VR. Of course, when we say there's technology, there's boon or bane. As much as we could use for the good of whatever the society and the applications, I'm sure these applications would definitely be doing good to us. I haven't put in a slide for that. Let me just go back to the slides again. Just a minute.
Education is empowerment, and people learn.
Let me share another one.
Imagine if there was a place where you could take the objects and the ideas in your head and make them real. There is a place like that. Welcome to the Holorum. Well, the reason for the Holorum is that Lowe's sells amazing products, but it's really hard to figure out how all of these possible things might come together in a real space, in the real world. With the help of a store associate, you'll be able to walk through and build your room. So your kitchen, your bath, and you're able to build it out with Lowe's products that look incredibly, incredibly real. There you go. All right, nice work. And now we can position that, get that just where you want it. So now we can go into the Holorum and check it out in full scale.
Sounds good.
Okay. And then you're able to go in and put these goggles on and be fully immersed in the space that you just created. Go ahead and just slip that on. And I'll be seeing what you're seeing here in the app. Oh, wow.
Oh my gosh. Oh, that's crazy.
You can move throughout various points in your room and view what it's going to look like, even changing materials like countertops, paint colors, or cabinet finishes.
I think we should change the paint color. I think we were looking at what,
Pacific Shoreline.
Pacific Shoreline. Can we change it?
I'll go ahead and change that right now. There you go.
Oh, wow. Oh, that looks much better. Yeah, it looks fantastic.
From there, you're able to take that room that you've built and you can port it over to Google Cardboard. It's a cardboard headset that you can take any smartphone and drop it into, and you can have a very similar experience to what you had inside of the store with you anywhere you want to take it.
You know, you walk out of the store, you have your finishes in your hands, and you have your Google Cardboard.
I can't believe how real it looks. This is a great way to make it tangible and to make it easier for the everyday person like me.
So with the Holorum and the other things that we've released from the labs, we're trying.
So this also shows that how well any of the departments, CS or IS departments, could actually collaborate with civil engineering departments or the mechanical engineering department and develop applications. So that's the reason why I have tried to show, different videos which can cover a lot of ideas probably for you to incorporate it in your project. So what I would suggest students is, look at making these very small gadgets. It could be with what is already available. Like I said, some of them are expensive, but most of these things could be built in a very, very simple form with the gadgets that you already have. Let me just go back to my slide again. Just a minute. Just a minute. So I'm almost done with the talk. By 3:20, I'll wind up. So if there are some questions, I can take those questions. So 2 to 3:30 was what we have planned. Yeah, so the point now, what you saw was all of these applications need goggles. So what are the limitations of having these goggles? That you can have only one person in that at a time. Each of these people, each of the person who wants to be in that immersive environment should have a gadget, should have a goggle, pair of goggles. So it is a limitation when you have mass audience for virtual reality, but AR is quite helpful because we said it is a real environment wherein you want to superimpose the digital environment. And also AR can be projected without goggles. So there is a possibility that you can have a projector with a controller which can choose the image that you want to have. Mobile phones can also be used for AR applications. So probably AR and VR are going to be, kind of the buzzword in the near future. If we have very good broadband services, if 5G becomes a reality, whenever that happens as quickly as possible, it would actually make the world a little more closer than what we think it is. Also, a lot of AI and ML applications along with data analysis. So people who are looking at becoming data scientists, there's so much of data to be analyzed. So a lot of scope for students to look at, doing an interdisciplinary project. Faculty members also look at these applications for AI and ML to even publish papers. People who have registered for PhD or would like to do that. So I'll just summarize whatever we've seen till now. That is, we've understood the difference between AR, VR, and mixed reality. We've seen what are the different components of hardware and software that go into making AR and VR happen. Also, we've seen the salient sensors and the other devices that are required in a typical headset for an AR VR application. And we've also seen applications anywhere from art and drawing right up to designing buildings or experiencing different colors in the room. So lot of scope for students to grow and understand in this particular field, or learning the technology or different platforms for AR and VR. I'll take a couple of questions now, and if we still have time, I have a few videos to show. So I think there are some questions. Let me just go back to the window.
Uh, Excuse me, ma'am.
Yeah.
There are some questions in the chat box. Can I read the questions, ma'am?
Yeah, I'm seeing them. I'll answer them. I think I can see. Yeah. Okay. Professor Sasindran Prabhu is saying, yeah, India will need another 2 years to get 5G. Yeah, it can be realized. I never said it can't be realized. But yeah, I just said 5G can enable it. AR VR can be realized. Yes, definitely. That's what I said. Good internet broadband services would actually help. People are doing it. It's not that they're not doing it. Current state of haptic feedback enabled. There are a couple of universities. In fact, some of the universities in Australia have done work on haptic feedback. So there is scope. When I say current, when you're asking current state, it is happening. There are people, because I've listened to a talk by an Australian expert who's done a lot of work in haptics. So it is there. Haptic feedback enabled AR VR is happening. Okay. Open source software specifically for AR VR, I am not aware of saying that it is for AR and VR, but there are multiple open source softwares which can be merged together to build an AR VR application. That is possible. So exclusively for AR VR, I am not aware of a specific open source software. Okay. Is there anything else, Dr. Vandana? What I could see, I have answered.
Ma'am, recently from 2-3 days now it is coming in WhatsApp. This IIT Madras has conducted this convocation. So it was on the virtual mode, and in that the student whom they wanted to recognize and give the
IIT Bombay
medal.
had done it. Yes.
Medal and all whom they
Yeah.
want to give, they have done it is through virtual reality only, right, ma'am?
Yeah. I saw that IIT Bombay.
Yeah.
Yes.
Okay. Yeah. That's what IITs have already started it following.
Yeah, but that was a different. Kind of, because anybody could actually see it. It's not that, this is what we're saying is you need that special goggles and all that.
But in that there was no special goggles. So was it an application of virtual reality or it was something else? That's what means I want to know.
I'm not very sure. I don't think I would like to comment on that, but it didn't need any goggles. Yeah, that's one thing I would, So it was more like an animation kind of a thing. Yeah, that's what he's saying here. Yeah, it was more of a virtual rendering. It was more like an animation than AR, VR. Like we have these cartoon movies, right?
Okay, it was
Like that.
that.
But I don't want to comment on it, so I would refrain myself from saying anything more than that.
Okay. Thank you, ma'am. Swati ma'am, if any questions are there from YouTube channel, you can ask.
Yes, ma'am. Actually, there is one more question in the chat box in Zoom from Ravikran DSR. What is the correct state of haptic feedback enabled?
Yeah, I answered that question. Current state, there are people working on it. Like I said, it's an Australian university, which I have listened to the person. So they are doing work on haptic feedback. So it's happening is what I'm saying.
Okay, ma'am. Thank you, ma'am. Thank you, ma'am, for answering the questions. We have come now to the end of the session. I would like to propose quote of
Ma'am, Geeta ma'am wants to continue more, or should we?
Yeah, I mean, I think it's okay. I think I've done enough. I just had another 2 videos, but that's okay. Let's wind up. No problem.
No, if you
want
want
have
to
the patience. Yeah, is it okay? Can I add
Yes,
them?
ma'am. Yes, ma'am. We have time till 3:30, ma'am. Yes, ma'am.
Okay, sure.
Yes.
Let me just do that. Yeah, let me just share that screen.
Virtual reality and augmented reality. They kind of sound like something you need a drug counselor to get through, don't they? But in fact, they're the hottest 2 technologies going these days. Let's learn about them so we can compare and contrast what each of them does so they wow you instead of overwhelm you. Augmented reality is when you look at the real world, but it's augmented with additional information or graphics in your view. Now, key to this AR concept is that the things are indexed to a location. That means they occupy a relevant place in your view, as opposed to moving with your gaze as you turn your head. And in many cases, you can interact with those visuals that are augmenting your view. AR can be had via a phone and one of the many AR apps out there, or for higher performance, you use dedicated AR glasses. Know that AR is increasingly being referred to these days as MR, mixed reality. It's part marketing term and part acknowledgement of AR's ability to augment the real world while also bringing in unreal elements. Glasses that augment your view without being indexed to a location and space are better referred to as connected head-up displays. Now, Google Glass was the infamous standard bearer of that sector, but more recently, Vuzix has shown their pending Blade, an impressive set of head-mounted displays that include integration of Amazon Alexa to help you drive what's displayed via voice. Virtual reality is when the world you're standing in is replaced with a virtual one. With some of these, everything you see and everything you hear is replaced with something computer generated. Now, the world that takes you to can be very naturalistic, actually, or extremely synthetic and fantastic. VR, you're surrounded in 360 degrees, and the space is 3-dimensional. Now, in its most ambitious forms, VR places are also navigable, as you can move through them and use your hands to manipulate things within them. VR can be done as simply as sticking your phone in a literally cardboard head mount or a little more upgraded plastic holder. But the attention these days is mostly on real deal head mounted displays. Until recently, these were quite cumbersome and always tethered to either a game console or a high-performance PC. But more recent versions acknowledge that tethering is going to be a non-starter for a lot of users. And instead, the new headsets build the electronics into themselves or maybe into a small companion processor you wear on your belt for a pseudo-cordless experience. The bottom line on AR or VR is that you really have to experience it to understand it and appreciate it. It's very hard to read an article or look at a video like this and understand the impact of these. They aren't like a lot of other.
So I think it was quite specific and understood as to the difference between AR and VR. So I think, yeah, okay. So yeah, I'm done with it. That was the last video that I wanted to show. I mean, I have more, but I think I will stop here. I think students have got an overview of what AR and VR is. My request is, include some of these concepts in your IoT project. Some of these can be done with as simple as OpenCV application. Somebody was asking me, is there a specific platform? So actually we have done one project. This was way back in 2013, I think. We didn't call it as AR and VR. So since we have another minute to go, I'll just answer this person's question. Are there any open source software? So this example, I'm sure students can try out this project. So what we had done was, you have a standard microprocessor or a microcontroller kit in your college. Two applications we had done. Like I said, then it was not called as an AR VR application. So what we had done was, you can click the photo of one of these components, process it, and then when you run your camera over that particular component, there will be an audio which will talk about the what shall I say, the data of that particular component. So if you run over a memory chip, the mobile phone will actually scan it, and then it will go to a processor. It will do this processing, and then there'll be an audio for about a minute or so talking about the component over which you moved the mobile phone. It will also give a display on a small LCD panel of what that particular component is. So a very rudimentary application of, very similar to AR and VR. We had also done an application which I'm sure students can try by keeping two cameras, very small cameras which you are generally using. It could be even a webcam. And we had, for this to kind of give you a very nice feel for the virtual environment, the way the camera should be placed is, how much of the spacing is there between the two eyes. So exactly in that, if you keep it, so the painting part of it, which I showed you, picking the color. So similar to that, we had done an application, so where it will click multiple pictures and it will stitch them, and it will give a 3D view of the particular room. So all these applications we have built on OpenCV. So if students or faculty are aware of OpenCV, these can be actually done with two simple webcams kept very close to each other. The distance between them should be, roughly an estimate of the distance between the two eyes. Click a couple of pictures which will be 2D in nature, stitch them and convert them into 3D. There are mechanisms to do that on OpenCV, and you can actually get a 3D view very similar to the AR VR application that you see. So in its rudimentary form, this can be done with OpenCV, which is a open source software. So I think that would also answer. Okay, stereo vision toolbox helps in generating, point clouds. So yeah, see, you're talking about the toolbox, but we had done without the toolbox. Like, we've generated with proper mathematical algorithms, processing the images, and then we have converted it. So it was proper coding. We didn't use any toolbox. What you're saying is right. There are toolboxes which can do this job. So yeah, that is to answer a part of his question. So I think probably Ravi Kiran BA is a professor, so he could actually encourage students to build these apps with Studio, or if they've already done it, good for us. So yeah, I think it's 3:30 and I think I'm done with my talk.
Thank you, ma'am. It was very informative. Swati, you can start.
Yes, ma'am. Okay, now we have come to the end of the session. I would like to propose vote of thanks. I express deep sense of appreciation to our guest speaker for taking time out of their busy schedule and accepting to be a part of this lecture session. This lecture was very informative and interesting. Thank you, ma'am.
Thanks for having it.
Thank you, ma'am. Now I would like to thank our CEO, Dr. KVA Balaji sir, and our principal and director, Dr. K. Ramanarasimha sir, for their support and guidance for conducting the today's talk. Thank you, sir. I would like to thank our management for their constant support. Now I would like to thank all the participants for being part of this lecture. I hope you must have got some good input from the today's talk. Thank you all. Now I would like to thank our HOD ma'am, Dr. Vandana Jha, and faculty of CSC department for successfully conducting today's lecture. Thank you, ma'am. Thank you all.
Thank you, ma'am. Thank you, Geeta ma'am. Thank you, one and all.
Now, feedback link is shared in the chat box. All of you, please give your valuable feedback for the today's session. Thank you, one and all. Feedback link is shared in the chat box. Please give your valuable feedback. Thank you, one and all, for participation.